Good morning. My name is Gabriel Nambila, and this presentation is for my literature review too for my remote sensing class. The article I picked to write my paper and make these slides is called Measuring the Quality of Life in the City of Indianapolis by the Integration of Remote Sensing and Census Data. And so, as you can see on the left, this is a map of the city of Indianapolis, and we decided to focus in particular in the Mario County in Indiana, USA. So the Mario County is one of the most um, populous area in the city of Indianapolis, and the methodology used in this paper is by using remote sensor data and then using 2020 tiger census data, and by bringing those two set type of data into a GIS software and then integrating them together to see what kind of score, coefficient, and um, correlation we could find with those two different type of data. As we know, remote sensing data is all about the physical world, such as elevation, vegetation, anything related to that. And census data or data you can download on the Tiger website is mostly about socio-economic information about the population. And then bringing those two sets of data together, we're able to find some deep insight that we couldn't find with those data independently. And so, for this particular research paper, they pick a few different variables in order to create that quality of life score. So, for example, they pick population density, housing density, green vegetation, impervious surface, temperature, median house income, median family income, per capita income, percentage of college graduate, median house value, median number of room, percentage of family under poverty, and employment rate. But also they imported some remote sensor data to create a more accurate coefficient. And so when we bring all those data together under one roof, we can create these correlation matrix between variable. So for example, on the top we see PD. PD stands for population density, and HD stands for house density. And we can see that the correlation is positive and 0.917. And when we look at other variable in the matrices, we can also see that, for example, GV, which stands for green vegetation, and PCI, per capita income, has some correlation, which mean the income in a specific area is has a correlation with how much greenery you find in this area. And so you might be wondering how we create this correlation matrix and which table were picked in those two different data sets. And so on this next graph, we can see the flow chart showing the analytical procedure. And so in the remote sensor data, in ETM plus, we pick band 1 through 5 and band 7, and and band 5 to 7, 1 to 5 and 7 are the band that contain green vegetation and impervious surface fraction. And in band 6, that's where you can find the surface temperature. And so when you bring those two block together or factor together, you can find them under the aggregate block volume that you can download from the Tiger Census online, and that you can download online. But for the remote census, and the census block group that can be downloaded from the Tiger website, where we can find all the socioeconomic variable. And then we bring all those data into a GIS software for factor analysis. And then once everything is proceeded, we can develop those factor, and based on this factor we can have a quality of life index. And with that quality of life index, we can make a regression analysis to determine or create a score of the quality of life in specific area based on factor that we previously picked. For example, on this map, the factor of one score, we can see the first factor score is the economic index. And we can see that most of the high economic index, I would say maybe above I would say with the green color or light green color, or near downtown, and all the rest is kind of on the surroundings, which totally makes sense that it's likely to have a high economic index around the big city, around downtown, and then having all those less fortunate areas surrounding those other area. On this next map, we can see that the second factor score was the environmental index. And as you can see on the previous map, most of the high economic index is around downtown. And if we go back into a graph, we can tell that with a high income, is really correlated to the population income. And that's why you can see that most of the green area with high environmental index also happen to overlap with the one with the high income area. On this third map, the third factor that we picked is crowdness, and we can see that most area that are crowded like is likely to be from low income neighborhood, which totally makes sense because in those area they tend to live in more secluded but more dense area. And we can see that near downtown, that's where this factor or this score of crowdness is a little lower, because that's where like housing tend to be more expensive, and that's where a few people can only afford it. And then finally, on the figure 6, when we try to bring everything together, and we can create this synthetic quality of life index or QOL index, we can see that the people or the area that's mostly shaded with a high quality of life index is the one surrounded the downtown area, and the one with a low quality of life index is the one around that high quality area. And the reason is why is when we go back to all the different graphs, we can see that the area around downtown tend to be the one with the highest income index, the highest environmental index, the lowest crowdness. And when we synthesize all those data together, we can see that it makes totally sense why the people living around downtown they have a high environmental index, making the most money, and the less crowded area tend to be the most happy or the one that have a better area. In conclusion, when we try to recap the methodology that we use for this research paper, we can see that remote sensing data and target sensing data, when they're all brought together under a GIS software, they allow us to do some deep analysis and to determine many correlation between table in those two separate different data type. And by doing some further analysis and synthesis, we can even come up with a quality of life score that can determine which area, in this case in the city of Indianapolis, is the one with a high quality of life score. and we can also see there's a correlation between income, environmental index, and all those different factors that affect a quality of life score. And all those correlation help us realize that in some there's a trend between um, a high score and a low score. For example, if you take the same methodology and apply it to a city that's not Indianapolis, for example, in a city like Houston, Texas, we kind of gonna find a similar pattern where the most area with the highest quality of life score we tend to be the one with the highest GDP, the highest population, um, with the highest income, and the one with the most vegetation. It's a trend I can see being replicable, and this the same correlation will show even if the city is different. And in conclusion, we can see that GIS can be used as a tool for decision making and develop deep insight about a city in particular, its population, and its physical representation. And the result that we got from all these analyses help us to determine that this correlation and this relation is accurate. And that was it for my second article review. That was Gabriel Nambila for remote sensing.